So we're looking at our level training units that we built here at PAC Works that we train our students on. This one particular unit that I'm going to demonstrate today, it's all set up. It has 2 transmitters on it, and both those transmitters are configured to measure the same level. There's one control system on it that's controlling the level, and we can switch from either transmitter to take over control of this control system. So each transmitter can itself be the primary element and send its signal direct to the controller. Let's move over here and take a closer look inside here to what we actually have. It's a fully automated system. Has a Micrologix Allen Bradley 500 Micrologix using RS Logix 500. Here's our control system. It has 10 and 12 and 24 volt power supplies because we have a 12 volt pump that we have running this system. We really try to keep everything low voltage. And the reason why is because we have students here, and the lower the voltage that we can teach them these controls, the better. No sense in having higher voltages for these kids. We really want them to be able to get their hands on it, but the higher the voltage, the more dangerous it gets. And that's something that we really are mindful of here. So we want to make sure that we give the kids the abilities to work on this equipment, and at the same time, we have IDP right there. You can see the IDP. It's in the center of the screen. We have a Badger research control valve. And we have a clear acrylic tank here that goes up to approximately 40 inches, but we keep it at 35, 36 inches. If you look in there, you'll see that's one float, and that's another float switch. And what we use those float switches for as our shutdowns in case something happens, maybe an air turns on. We have a pressure switch right here. This pressure switch is here, and what that does is the pressure switch acts as a permissive to not allow the certain things, the pumps and things like that, to be activated until the pressure in the system is up, okay? So that's what we have. I'm gonna go right here, and I'll give you a little bit of the control. I'll manipulate the HMI just a little bit, let you see exactly what we have going on there. It's pretty cool little deal. We built all of this here, right here in our shop. When we first started this, we didn't have any money, and so there was no way that we would be able to actually get this done without doing this ourselves. You know, we had no funding, we had no help. But what we did have was the ability and the expertise and the desire to get it done. And we took that right there and we used that, and it's taken us a couple of years. We've actually been in business since 2016. It took us a couple of years, but we were able to finally get all this done to where we could train our students properly, and we had the equipment that we needed to make this stuff look good, and that's what we did. I like that right there. It's not perfect, but it'll be okay. Why don't you invest in the cameraman? I think we can't do stuff on the fly, you know, like we want to, when we want to do it, you know, right now. Cameramen are good, but we have to schedule them. I think that'll be okay. So here we go. We have the controls right here, and what you'll see is we have pressure switch is active. If I turn off the pressure and allow this to bleed out, the pressure switch will become inactive. We have pump start, pump stop, on off indication. The deviation is stable, and what that deviation stable means is that our control signals are within a certain percentage of one another, and that's important for us. And then this is our control, and so from here we can control the set point, and this is the output. We can put it in manual and control the output in that way. We can do that, and from here we can determine which transmitter we want to control by deciding which one is in standby and which one is in service. And that's pretty cool too. You know, this is the type of system that you may possibly see in the field. You know, if they're working on one transmitter, they'll put that one in standby while they work on the other transmitter, and the system will never ever have to stop running. Okay, so what I'm going to do now, I'm just going to start this system, and I'm going to start this system here, and I'll pan over and we'll see kind of what happens when I push start. The pump comes on, and if I pan over here, you'll see we have water flowing in this system now. See, we have water flowing, and the system's going to come up to level where it's supposed to be. So I'm going to set the level at about 50%, and we'll see this system get to where it needs to be. So right there, that's about 50%. We have this transmitter range 0 to 35, so I'm looking for this system to line itself out at about 17 inches, 17 and a half inches. What's the range on this one?
It's actually 0 to 30.
Or it's 0 to 30? Okay. So at 0 to 30, this one should line out at about 15, and that's what we have. It's lining out at about 15 inches. Oh, that's right, because you said 22 and a half was 75, didn't you?
Correct.
Okay, yeah. All right. So I'm going to take this up to 75. I'll get it. That's pretty close. That's 72. And we should see this thing go up to about 22 and a half, about 22, between 22 and 22 and a half inches, 21 to 22, something like that. This at 72. I think that's good enough to show where we want this level to come. Pump not turned on?
The compressor's not on.
That's okay.
So that's good. See, you showed them what the compressor does, so the air went out.
So what happened is we forgot to turn on our compression, so the air went out and it shut the system down, and that's what it was supposed to do. That's not a real big hiccup.
Go ahead and turn it on.
Huh? Oh, pump can be turned on now?
Mm-hmm.
Okay. So at least we know the shutdown's working. Yeah, it's about 22. And here's the graph. So this graph right here, the thin white line that you see, that's our control signal. And the green line is going to be our set point. That's where we want the system to actually be. And then we have a red and a yellow pin line, and those are our transmitters. One is red and our transmitter number 2 is yellow. And so that's kind of where we want to be. And if we pan, I'm going to pan back over here to our level, and it should be coming up to about 22 now that it's now that we got air back on the system. That's fine. So that's basically our level trainer. We do it with the I to P, and here's the I to P right here. Right there, the gauge going to the red Badger research valve is a 3 to 15 PSI, 4 to 20 milliamp input, 3 to 15 output going to the Badger research valve, and it's perfect, you know, small, like that way we can use that to show our kids, you know, I to P transducers. You know, that's the most common transducer that they'll see out there in the field, is the I to P transducer. Okay, thank you. Set up above our transmitters here, we have a couple of Fluke 789 process meters. These Fluke 789 process meters are really the only process meters that we use. I'm sure that there's others, but we don't use any others. This is what we use in our industry. This particular process meter is considered your bread and butter. And what they say about that is, if you don't know how to use this process meter, you will not make it very far in this field. So let me take a little break here, and then we'll come back and we'll talk about these 2 process meters that we have set up here and what they're doing. Be right back.